Hello everyone, welcome to the GATE and PTL lecture course. Today we are going to solve some GATE problems. The space between two plates of capacitor carrying charges plus Q and minus Q is filled with two different material of dielectric. Now across the interface, which of the following quantity is correct? Whether these or E are continuous or they are both discontinuous or one is continuous, other is discontinuous. So I think you are familiar with these boundary conditions. Initially, we have also explained that the parallel component of electric field are continuous but perpendicular is discontinuous by sigma upon epsilon naught. Parallel means if we have this kind of interface, so parallel to this interface, if you place your palm above this surface, you can know that any vector field which is not intersecting this plane will be parallel. So E parallel means parallel to the interface, and above and below means the above and below to this interface. So basically, if you try to see this condition here, this parallel to the interface means we are talking about these components, and above and below means we are talking about one side and the other side of the interface. And the perpendicular component is discontinuous by sigma upon epsilon naught. Similarly, if we wanted to write this condition in terms of D vector, it will become D perpendicular about D perpendicular below equals to sigma free charge density. Now, in this case, it is not given to us that there is any charge across this interface. So we assume that the sigma free charge is zero. So if we assume that, then this term will imply D perpendicular above minus D perpendicular below equals to zero. That the perpendicular component of these kind of continuous. They are equal. But if you look at the parallel component of this D vector, so it is given that the parallel component of electric field is continuous. So multiply epsilon naught on both sides. Since D vector is given by epsilon naught E vector plus B vector, so we just put epsilon naught E. This term I just take this side. So D parallel above minus D parallel below. This term is coming. So this term parallel polarization terms, they are the bound charges, and they are going to create, since this positive and negative charge will create a electric field in this direction. So this polarization component is going to be different on one side and this is going to be different on another side. That means this quantity is not going to be zero. It means that the D parallel above minus D parallel below is not zero, so they are not equal. That means parallel component of D is discontinuous across the surface. Similarly, if you talk about the electric field component, the parallel component of electric field is continuous, but perpendicular component of electric field here is discontinuous by discontinuity of sigma upon epsilon naught. So both this component of D and E, they are discontinuous. So whenever you are going to ask this type of question, just switch towards the boundary condition.